Hello, class. This is Mr. Hart. In this podcast, I want to go over the last part of Chapter 5, Chemical Bonds. And if you remember last time, we were talking about the three different types of bonds, which are covalent bonds, ionic bonds, and metallic bonds. Okay, covalent bonds between nonmetals, ionic bonds are between metals and nonmetals, and metallic bonds are just between metals. Okay, so you can kind of think of those as the three main classifications of bonds. Okay, but there's a specific type of bond that is between molecules that I want to talk about. But before we get into that, let's talk about polarity. Okay, so polarity is the tendency of molecules that have positive and negative poles. So in order to visualize what we're talking about, let's think about a molecule of water, H2O. Okay, so if you remember, water has the one oxygen in the middle and then the two hydrogens coming down to the side like this. Okay, so here's oxygen, and then these are the two hydrogens. Okay, and if you remember from the molecule shape lab that we did, it kind of has this bent shape to it. Okay, it's not straight, it's not linear, it's got this nice bend to it. And that's because it had those electron pairs at the top. So there's two electrons here, two electrons here. Okay, and this is what a water molecule looks like. Okay, so if you think about it, this molecule is not symmetric, right? It has this bent shape, but it's also not symmetric in charge because these two electrons right here, okay, and these two electrons right here are both on the same side of the oxygen. So this side is more negative than this side. Okay, so we can even denote that and say this is kind of the negative side of the molecule, and this is the positive side of the molecule. Okay, so it has poles, electric poles, a positive side and a negative side. Okay, that's the term polarity. Okay, so this would be a polar water molecule. And again, you can kind of think of it like a magnet, right? Magnets have a north and south pole, right? Well, this molecule has a positive and negative pole. Okay, and so what that means is if I have two water molecules next to each other, they'll kind of line up positive to negative and positive to negative, kind of like a magnet. Two magnets would line up north to south and north to south. Okay, so we have this nature of the molecule so that it's not symmetric in shape or charge. Okay, and so we call it a polar molecule. Okay, so that's polarity. This difference in charges on a molecule because of where the electrons are hanging out. Basically, that's what you would say. Okay. And so that's a polar molecule. An example of a nonpolar molecule would be like CO2. Okay, so CO2 doesn't have any free electrons, so it just has the two oxygen on the side and the carbon in the middle. Okay, no poles, no positive, negative side, just symmetric. Okay, so this would be polar, a polar molecule, and this would be nonpolar. Okay. And again, excuse my handwriting. I'm writing with a touchpad. Okay, so there you go. Polar, nonpolar. Hopefully that makes sense. Okay, so some molecules are just going to have these poles because of where the electrons like to hang out or where they like to roam around. Okay. All right, so now that we have polarity, if we think about polar molecules, they have this positive and negative side, and I said they can kind of line up like magnets do. Okay. And when they line up, this connection between the molecules happens. We call it a hydrogen bond. Okay. So a hydrogen bond is a natural connection between the positive and the negative poles of two polar molecules. Okay, so here's our water molecule right here. Okay, positive side on the hydrogen, the negative side because the free electrons are up here. And so these positive side hydrogens are going to kind of connect to the negative side on the oxygen side. Okay, so this is called a hydrogen bond. It's not a chemical bond. They're not giving or sharing electrons. Okay, it's not quite as strong as a chemical bond, but there is still a connection there. They want to be near the positive and negative sides. Okay, and so this is between molecules, so we call it an intermolecular force or an intermolecular bond, whereas the other ones we've been talking about is intramolecular intermolecular, within the molecule. Okay, so a hydrogen bond between molecules are intermolecular. Okay, and so again, it's just like a magnet. North and south, positive and negative, they want to line up. Okay, because of this natural connection. Okay. Now, hydrogen bonds are cool because they give us a lot of unique features in nature, and one of the most important ones is that they help water expand when they freeze. Okay, and sometimes you don't think about this. Have you ever thought about why water expands when you freeze it? Because any other material, if you turn it into a solid, the molecules are going to get closer, right? We learned that in the kinetic theory of matter. Okay, solids are going to have the closest molecules, but water actually expands when you freeze it. And this is because of these hydrogen bonds, okay? So these positive sides line up with the negative sides, okay? And when they do that, they make this kind of unique, kind of hexagonal shape within the ice. And so as they come closer together, they can't just mush together because of their polarity. And so they will actually create this hexagonal pattern, and it'll actually cause it to expand rather than contract. Okay, because it can hold this shape because of hydrogen bonding. So it's really cool. If we didn't have this, okay, think about it. Ice floats on top of water, right? In the winter, the ice forms on the top of lakes and stuff like that. If this didn't happen, the ice would sink to the bottom of the ocean. Okay, this would be really bad because it would kill a lot of ocean life. It just keeps stacking up on the bottom and the bottom. Okay, probably not be the best thing for us. Who knows if a lot of animals in nature would have even evolved if this would have been the case. Okay, so it's really good that water actually expands, because otherwise life would be a lot different. Okay, and so again, it's because of this hydrogen bonding, this polarity of the molecules connecting. Okay, and I recommend watching this YouTube video from SciShow. They do a good job of explaining why this happens. And so yeah, if you have the chance, look up that link, because it does a great job of explaining hydrogen bonds. But that is really it for the chapter. Okay, so we've talked about all the different types of chemical bonds. We talked about hydrogen bonds. And so hopefully this all makes sense, and hopefully you can prepare and get ready for the test. Again, go to the review online to prepare for the test. But let me know if you have any questions, and thank you for watching.